In today's lesson, we will master exponential and logarithmic functions. You will learn to identify their general forms, sketch their graphs, and understand the critical inverse relationship between them. These functions are fundamental in additional mathematics because they model real-world growth and decay, and mastering them is essential for securing a top grade in your Cambridge IGCSE exams. We will start with the properties of exponential functions, move to logarithms, and then look at how they mirror each other across the line y equals x. Today, we are discussing exponential functions. An exponential function is a function where the variable x is in the exponent. The most basic form is y equals a to the power of x, where the base a must be positive and not equal to 1. In your IGCSE syllabus, the most important base is the mathematical constant e, which is approximately 2.718. We call this the natural exponential function. In the exam, you will often see the general form y equals k times e to the power of nx plus a. Let's break down the key features you need for sketching. First, the horizontal asymptote. This is the value the graph approaches but never actually reaches. For this general form, the horizontal asymptote is simply y equals a. Next, the y-intercept. We find this by setting x to 0. Since e to the power of 0 is 1, the intercept is always the point 0, k plus a. The domain is always all real values of x. However, the range is restricted by the asymptote. If k is positive, the graph stays above the asymptote, so y is greater than a. The shape of the graph depends on the base and the coefficient of x. When the base is greater than 1 or the power is positive, the function is ascending. It grows faster and faster as x increases. If the base is between 0 and 1, or if we have a negative power like e to the power of negative x, the function is descending. It represents exponential decay. Let's apply this. Suppose we need to sketch y equals 3e to the power of 2x plus 1. Step 1. Identify the asymptote. Here, the constant term is 1, so we draw a dashed horizontal line at y equals 1. Step 2. Find the y-intercept. Setting x to 0 gives us 3 times 1 plus 1, which is 4. Step 3. Since the coefficient of x is positive 2, the graph is ascending. We draw a smooth curve starting just above the line y equals 1 and rising through the point 0, 4. Logarithmic functions are the algebraic inverses of exponential functions. While the exponential function asks, what is the result of this power? The logarithm asks, what power produced this result? In additional maths, we focus on the natural logarithm, written as lnx, which uses the base e. The general form you will encounter is y equals k times the natural log of the linear expression ax plus b. Unlike exponential functions which have horizontal asymptotes, logarithmic functions have vertical asymptotes. This occurs where the argument, the part inside the bracket, is equal to 0. Solving at x plus b equals 0 gives us the line x equals negative b over a. This leads to the domain. Since you cannot take the logarithm of 0 or a negative number, the function only exists where the argument is strictly greater than 0. For the shape, if the base is greater than 1, the graph rises steeply from the asymptote and then flattens out. If the base is between 0 and 1, it falls from positive infinity and flattens as it moves right. Let's work through an example. Suppose we want to find the domain and asymptote for the function y equals 2 times the natural log of the quantity x minus 3. To find the vertical asymptote, we look at the argument inside the natural log. We set x minus 3 equal to 0, which gives us the vertical line x equals 3. The graph will never cross this line. For the domain, the argument must be strictly positive. Therefore, x minus 3 must be greater than 0, meaning x must be greater than 3. To find where it crosses the x-axis, we set y to 0. Dividing by 2 gives 0 equals the natural log of x minus 3. Converting this to exponential form, e to the power of 0 equals x minus 3. Since e to the 0 is 1, we find x equals 4. When sketching, we draw the asymptote at x equals 3 and show the curve rising from the bottom and crossing at the point 4, 0. The most critical link between these two functions is that they are inverses of each other. This means they undo one another. Algebraically, if y equals e to the power of x, then x must equal the natural log of y. Visually, the graph of an inverse function is a reflection in the line y equals x. Notice how the features of the exponential function swap to become features of the logarithmic function. The y-intercept of the exponential function, 0, 1, reflects to become the x-intercept of the log function, 1, 0. The horizontal asymptote y equals 0 reflects to become the vertical asymptote x equals 0. This symmetry is a favorite topic for Cambridge examiners. You might be asked to sketch both on the same axes to demonstrate this inverse relationship. Always remember to include the line y equals x as a dashed guide for your reflection. Let's look at a Cambridge-style challenge that combines these concepts. Consider the function f of x equals 3e to the power of 2x minus 6. Find the coordinates of the points where the graph of f crosses the axes. For the y-intercept, we set x to 0. 3 times e to the 0 is 3. 3 minus 6 gives us negative 3. For the x-intercept, we set f of x to 0. We add 6 to both sides and divide by 3 to get 2 equals e to the power of 2x. Taking the natural log of both sides gives ln2 equals 2x. So x equals half of ln2. State the equation of the asymptote of f. Looking at our general form, the constant term is negative 6. Therefore, the horizontal asymptote is the line y equals negative 6. Find the expression for the inverse function f inverse of x. To find the inverse, we swap x and y, then rearrange for y. First, we add 6, then divide by 3. To get y out of the exponent, we take the natural log of the whole left side. Finally, we divide by 2. Mistake 1. Confusing the asymptotes. Remember, exponential functions have a horizontal asymptote because the y value is limited. Logarithmic functions have a vertical asymptote because the x input is limited. Mistake 2. Incorrectly identifying the range. For y equals ke to the power of nx plus a, students often forget that if k is negative, the graph is reflected below the asymptote. So the range would be y is less than a, not greater than a. Mistake 3. Logarithm of a negative number. Never try to calculate the log of a negative value or 0. If your calculation leads to this, check your domain or your previous algebraic steps. Tip 1. Always label your intercepts and asymptotes clearly. Examiners look for the dashed line representing the asymptote and its specific equation, like y equals 3. Tip 2. When asked to sketch the inverse, draw the line y equals x first. It acts as a mirror and ensures your reflection looks mathematically accurate. Tip 3. Use exact values where possible. Unless the question asks for decimals, leave your intercepts in terms of natural logs, like x equals half ln2. This demonstrates mathematical maturity. It is time to test your understanding. Please pause the video and attempt these 3 questions. Easy. Find the y-intercept and the horizontal asymptote of the function y equals 5e to the x minus 2. Medium. State the domain and the equation of the vertical asymptote for y equals the natural log of 2x plus 8. Hard. The function f is defined by f of x equals e to the 3x plus 4. Find an expression for the inverse function f inverse of x and state its domain. Take a moment to solve these before we move on to the solutions. Let us look at the solution for the easy question. For the y-intercept, setting x to 0 gives 5 minus 2, which is 3. The horizontal asymptote is simply the constant term, so y equals negative 2. For the medium question, the vertical asymptote occurs where the argument is 0. Solving 2x plus 8 equals 0 gives x equals negative 4. The domain requires the argument to be positive, so x must be greater than negative 4. Finally, the hard question. To find the inverse, we swap x and y and rearrange. Subtracting 4 and taking the natural log gives ln of the quantity x minus 4 equals 3y. Dividing by 3 gives the final expression. The domain of the inverse is the range of the original function. Since e to the 3x is always positive, the original function is always greater than 4. Thus, for the inverse, x must be greater than 4. To summarize our lesson on logarithmic and exponential functions, first, remember that exponential functions have horizontal asymptotes defined by the vertical shift in their general equation. Second, logarithmic functions have vertical asymptotes that occur where the argument of the log is 0. The function only exists where this argument is positive. Third, the natural exponential function and the natural logarithm are inverses. Their graphs are perfect reflections of one another across the diagonal line y equals x. Finally, always provide exact values for intercepts and clearly label your asymptotes to secure full marks in your Cambridge exams.